be starting off V1 with quadratics. This is the first video of quadratics. We're going to be solving equations and sketching their respective graphs. So for this one, we're only going to be dealing with equations that require middle break and the quadratic formula. Completing the square method जो है वो हम in the next video देख लेंगे. Now here let me select red. And let's go over a few examples जो मैं already कर चुका हूँ. 2x squared plus 7x minus 4 is equals to 0. A simple quadratic equation. ये first let's see के what does 2 multiplied by 4 give us? So it gives us 8. And what are the factors that make up 8? एक तो 4 and 2 है themselves. 4, the product of 4 and 2 gives us 8. And another combination is 8 multiplied by 1. तो in middle term break we know कि हमें ऐसे फैक्टर ढूंढने होते हैं जिनका प्रोडक्ट जो वो बने from the first and third terms और फिर जो उसका सम या बेसिकली सम जो होगा वो मिडिल टर्म के इक्वल होगा. Oops. Alright, so the product is equal to the first and third, and the sum is going to be equal to the second term. तो ये कुछ key points होते हैं when doing the middle term break. So in this case we have 2 and minus 4 which gives us minus 8, or then for the sum we have 7. So we get 7 when we subtract 1 from 8. So the second combination over here of these factors makes more sense, 8 and 1, क्योंकि 4 and 2 में the most we're going to get is 6 and the least we're going to get is 2. So it really doesn't make sense, we're not getting 7 anywhere. So we go with 8 and 1, 2x squared plus 8x. So basically what we did is we broke down the middle term into the two factors. तो यहाँ पे 8 और 1 आ गया. यहाँ पे 1 लिखते नहीं है but in this case I am writing 1. तो यहाँ पे we subtracted 1x from 8x to get 7x और फिर इस तरीके से हमने अपना first step कर दिया है. Now in the second step we're gonna divide the whole equation. We're gonna divide the whole equation into two parts. So this is gonna be our first part and this is gonna be our second part. Alright, so it doesn't matter कि यहाँ पे minus sign हो या plus sign, it's always gonna be like that because the moment the second term is finished, so the first part of the equation is already formed. Okay, so once we've divided the equation into two parts, हम common लेंगे यहाँ पे. तो 2x squared plus 8x has the common of 2x. तो 2x common ले लिया यहाँ पे, we are remaining with x plus 4. अब goal ये होता है कि if you're doing the middle term break correct, so the factor which you receive over here should be the same in what you receive in the second part of the equation, or it must be your goal to achieve the same factors in both parts of the equation. So we know कि minus x minus 4 में कुछ भी common नहीं है except the minus sign. So we take the minus sign as a common to achieve x plus 4, and now we can see that both parts of the equation have x plus 4 as a common factor, which means that the middle term break is correct. अब यहाँ पे we are now left with two factors, x plus 4 which we have found out and 2x minus 1 which we are left with. So this is our second factor. So these are the two factors, 2x minus 1 and x plus 4, equating to 0 as stated in the equation. यहाँ पे जो था. Now now we have two equations here, 2x minus 1 and x plus 4, two expressions basically, and we're going to be taking each of the expressions as a subject. So to make this happen, what we're going to do is, for example, we're going to be taking 2x minus 1 And to remove x plus 4 from this equation, we're going to be putting it to the other side of the equation, dividing it by 0, making it 0 is going to be divided by x plus 4, giving us 0. And once we solve this, we're going to get x is equal to 1 upon 2. So this is our first factor, and the same process is going to be followed for x plus 4, where we divide 0 by 2x minus 1 to get 0 once again, and we're going to be left with x is equal to minus 4. Okay, so these are the two factors that we get, and as we can see, it was already written over here. So these are the two factors. Now this is the graph, and basically quadratic equations have a graph named the parabola. It's either a smiley face or a sad face, and it's always this type of curve. So for different types of equations, there are different types of curves. For example, for cubic curves, you usually see this type of curve. For exponential, you see these ones, and so on. So this is called a parabola, and we're going to be diving deep into these later in the video, but for completion's sake, what's happening here is that these two values are the x-intercepts of this curve over here. So the x-intercept is when the curve cuts the x-axis, basically when the y-axis is equal to 0, and we get x equals to 1 upon 2 over here and x minus 4. Well, I think this is wrong, because x minus 4 appears earlier than 1 upon 2 in the number line. So let me just fix this. Here we get x minus 4, and here we get x equals to 1 upon 2. So this is our number line right here. This is our number line, and this curve over here cuts the number line at these two values. Yeah, so this is what solving an equation gives us. It gives us the x-intercept, and for this case it gives us the x-intercept. But if the equation were to have something like 2y square plus 7y minus 4, then of course it would be giving us the y-intercepts. Okay, so this is how it works. This is the second example. And here we have 5x squared minus 2x minus 4. So we go over the same rules. We check the product, and I'm getting 5 and minus 4. The product gives us 20, and here I'm getting the sum as minus 2. So 20's factors can be 10 and 2. That's one combination. The other is 4 and 5. And yeah, I think these are the most I can think of. So with these factors, you can see that there's nothing that can give us a sum of minus 2. And when the middle term break is not possible, we go with the quadratic formula. So this is the quadratic formula. You all must have studied this. X equals to minus b plus minus b squared minus 4ac, the determinant, upon 2a. Yeah, so this is the equation, and the first term's coefficient is a, the second term's coefficient is b, and the third is c. So we simply substitute the values into the formula and we get our answer. These are the x-intercepts for this question, and this is the number line over here, and this is where the curve cuts the x-axis. It cuts the x-axis at the points minus 0.7165 and 1.1165. Now these are two more questions. If you guys like to solve them, you can. I'll be solving the first one, so let me just drag this down. Okay, so okay, let's open this up. So this question is a bit different because it's not in the same format as I've shown you guys previously. So we need to solve this to bring this equation to that form where you can clearly see ax squared plus bx plus c equals to 0. The 0 is important here because as you can see there's no 0 over here, there's a 3. So we need to remove this. Okay, now we're going to be opening this equation up. So simple expansion to x plus 4 minus 1 x plus 4 equals to 3. We get this. Now we're gonna group the similar variables. So there's only one x squared term. 8x minus x is 7, and minus 3 is gonna jump over to the left hand side, giving us minus 7, and we're remaining with 0. Now if you guys want to save time, what you can do is open up your calculator, go to the polynomial equation settings, and this usually depends on the type of calculator you have. So once you go to the equation settings, you're gonna be receiving a polynomial equation setting along with a simultaneous equation setting, and you're gonna go over to the polynomial equation setting and type in the a, b, c values, 2, 7, minus 7, and once you input these values you can figure out whether the equation supports middle-term break or it doesn't by the type of values you receive. So if you receive a decimal value, then that means that the quadratic formula is being applied and middle-term break is not supported. Otherwise you can carry on with your middle-term break. And this is just to show for the working, because you can't just sit around in the exam hall and figure out what products and what sums are available with what factors you have. So this is just a quick shortcut, and yeah, I'll be using these for future videos as well. So with the first value I'm getting okay, so for working sake, let me just write these. And yeah, the first value I'm getting is 0.811, so I know that middle-term break is not supported here. And why isn't it supported? Well, for this explanation, let's see. So our product is 14 and we need our sum as 7. So the factors over here that make up 14 are 14 and 1 itself, 7 and 2, and nothing else. So this is what leads to the failure of the middle-term break, and that we can achieve a sum of 7 with these factors for this question, which is why we use a quadratic formula. And the way I figured out that the quadratic formula was being used is because the lack of integers, and that I was receiving my values in decimal format. So for working sake, let me just show the values being imported. Okay, Okay, I think that's enough. Now the first value I get is 0.8. Wait, let me just do one final step. 49 plus 56 gives us 105, I think. Yeah, 105. Okay, so what happens from here on out is there's two formats to this equation now, one having the plus sign and one having the minus sign. Alright, and yeah, so I'm not going to be solving these values, I already have them on my calculator. So the first is 0.8117 and the second is minus 4.3117. Oh, and the rules for the writing of decimal places is that we go up to 4 decimal places and maybe 3 significant figures. It usually depends. I'm going to be specifying these in the next videos, but for a while I'm going to be using 4 decimal places. Okay, so these are the values that I get, and to make a number line for this, what I can do is go here. This is my number line, and my first value is minus 4.3117. Second value is 0.8117. Obviously 0 is going to be here, a bit closer to this first value, but that doesn't matter since the curve is going to be cutting at these values. Oops, let me make it a different color. Yeah, so the curve is going to be cutting at these values, and yeah, so we have figured out how to solve equations, simple equations, and how to sketch the graphs. Now time to dive deep into the curves. So we know that we have quadratic equations in this format, and the highest degree is 2. Okay, so this is our format for quadratic equations, and this ain't gonna change. But the thing that changes in curves is the way they are drawn. So they're drawn in 2 ways. One's a smiley face and one's a sad face, or an yeah, so we're just going to be referring it to as that. And we get a smiley face when the coefficient of the x square is greater than 0, meaning if it's positive. So when a is positive, we get a smiley face, and when a is negative, we get a sad face. And these are the x-intercepts, and the moment when the gradient of the curve is 0 is our stationary point. Okay, so this is a general term called the stationary point, and the stationary point can either be a minimum point or a maximum point. It can be minimum points or maximum points depending on the coefficient of the x square term. And yeah, so these are the x-intercepts, and this is the minimum point, and there are 2 sides to the minimum point. The minimum point basically determines the line of symmetry over here. This is the line of symmetry. So when we fold the curve exactly into half, we're gonna get equal halves. Alright, and yeah, so there are 2 parts to the division of this graph. On the left hand side, we can see that the gradient is decreasing. Alright, so it has a negative gradient, which means that this function is decreasing. Okay, let me write this again. Decreasing function. Here we have a positive gradient because it's rising up. It's rising up from here, it's rising down to here. So this is a positive gradient, meaning that the function is increasing. So these are different terminologies and the examiner can test your knowledge on these. So it's important to have these in mind. And the same can be applied for this curve over here. I'm not going to be writing all that again, but I hope you got the general idea. And these curves are called parabolas in the case of quadratic functions. And yeah, so there's that. So we sketch graphs and we solve simple equations. In the next video we're going to be talking about completing the square method.